Welcome back to Outside Views Military. Today we're diving into one of the critical defenses against air threats, surface-to-air missiles or SAMs. When you think about military defense, especially in the skies, SAMs are one of the most powerful deterrents out there. And these systems are specifically designed to counter airstrikes, protecting valuable ground assets, infrastructure and troops from hostile aircraft. In a world where air superiority often dictates the success of military operations, SAMs have become an indispensable part of modern warfare. Now, let's start with the basics. What exactly is a surface-to-air missile? In simple terms, a SAM is a missile designed to be launched from the ground and target aircraft in the sky. And the purpose is clear: neutralize the enemy's air advantage by intercepting and destroying their planes, helicopters, or even drones. Unlike air-to-air missiles, which require an aircraft to fire them, SAMs offer a ground-based solution to counter aerial threats. And they don't just protect the front lines. SAMs are deployed to defend cities, strategic facilities, and of course vital infrastructure. And one of the main reasons SAMs are so effective is their versatility. They come in various forms, from a man-portable system that a single soldier can carry to massive complex systems that require a full crew and are mounted on vehicles or stationed at permanent sites. Some systems are mobile and can quickly relocate to avoid detection, while others are fixed, set up to protect high-priority targets like military bases or government buildings. And this adaptability makes SAMs a valuable asset in both offense and defense. And to really understand how SAMs work, we need to look at the components involved. A typical SAM system includes radar, command and control units, and of course, the missiles themselves. The radar is the eyes of the system. It detects incoming threats and tracks their movements. Once a target is identified, the information is relayed to the command unit, which analyzes the data and makes a decision: engage or hold fire. If the decision is to engage, the missile is launched, guided by precise targeting systems to intercept the threat. Now, radar is a key part of any SAM system. It's responsible for detecting, tracking, and guiding the missile toward the target. Modern radar systems are incredibly advanced. They can differentiate between multiple targets, track their speed, altitude and direction, and even predict their flight path. And some radar systems can detect stealth aircraft, which are specifically designed to evade radar detection. This capability alone can make SAMs a formidable obstacle for any airstrike plan. Let's talk about missile guidance. SAMs don't just fly straight at their target. They use sophisticated guidance systems to reach their destination. And there are different types of guidance used in SAMs, such as command guidance, where the missile is directed by the ground station, and homing guidance, where the missile locks onto the target and adjusts its path accordingly. Some systems use semi-active radar homing, which involves both the ground radar and the missile working together to track the target. Then there's active radar homing, where the missile itself has a radar that independently tracks the target once it's close enough. And these guidance methods ensure that the missile can adapt to any evasive maneuvers an aircraft might attempt. Modern SAM systems also have a feature known as fire and forget. This means that once the missile is launched, it doesn't rely on further input from the ground system. It is literally autonomous. And this is especially useful if the SAM system has to relocate or if the control station is at risk of attack. Fire and forget technology has revolutionized SAM capabilities, giving them a higher chance of success against fast-moving, agile targets. Now, SAM systems aren't just effective against fighter jets. They can engage a wide range of aerial threats, including helicopters, drones, and even ballistic missiles in some cases. For example, systems like the S-400 or the Patriot missile system are designed to intercept and destroy ballistic missiles, making them vital for countries facing missile threats. In the age of drones, SAMs have also adapted to detect and target these smaller, often slower moving aerial threats. As drones become a more common tool in modern warfare, SAM systems are evolving to meet this new challenge. But SAMs aren't without their limitations, I must say. And one of the main challenges is that they are heavily reliant on radar. While radar is powerful, it's also detectable. If an enemy can locate the SAM radar, they can attempt to jam it or launch anti-radiation missiles designed to home in on radar signals. And this makes radar both the strength and the vulnerability of SAM systems. To counteract this, some SAM systems use passive radar or frequency hopping, making it harder for the enemy to detect and jam their radar. And another challenge is the low altitude issue. SAM systems are highly effective against high-flying targets, but low-flying aircrafts and helicopters can evade radar detection by hugging the terrain. And this is known as terrain masking. And to address this, some SAM systems use a combination of radar and optical or infrared sensors, allowing them to detect low-flying threats that are otherwise hidden. And there are different types of SAM systems used worldwide, each with its own unique features and capabilities. One of the most famous examples is the American-made Patriot missile system. The Patriot is known for its ability to intercept not just aircraft but also ballistic missiles, making it a versatile and highly respected defense system. It's been deployed in various conflicts and it is a cornerstone of air defense in many countries, including my home country. Another well-known system is the Russian S-400. The S-400 is considered one of the most advanced SAM systems in the world. It has a longer range and can engage multiple targets simultaneously, including stealth aircraft and ballistic missiles. And countries around the world are interested in acquiring the S-400, and it's becoming a symbol of advanced air defense capability, even with all going on at the moment. China also has its own advanced SAM systems, such as the HQ-9, which combines elements of both the Patriot and the S-300. The HQ-9 is a powerful system capable of engaging a wide variety of aerial targets and is a key part of China's air defense network. For shorter range defense, there are systems like the NASAMS, the Norwegian Advanced Surface-to-Air Missile System. It's a complicated one, which is a mobile and highly flexible solution for engaging threats with a limited range. And then there's the German IRIS-T, a versatile system that can be used both for air-to-air and surface-to-air defense. And each of these systems offers different capabilities, but they all share the same purpose: protecting against aerial attacks. In recent years, SAM systems have proven themselves in various conflicts around the world. They have been used to protect cities, military bases, and other critical infrastructure. SAMs have the ability to limit an adversary's air advantage, creating no-fly zones and restricting air operations. And even the threat of a SAM system can deter an airstrike, as pilots are aware of the risks involved in facing these powerful defenses. And while SAMs provide essential protection, they are also part of a broader air defense strategy. In many cases, SAMs are integrated with fighter jets, anti-aircraft artillery, and early warning systems to create a multi-layered defense network. And this layered approach increases the chances of intercepting and neutralizing incoming threats. No single system is perfect, but together they create a formidable shield against airstrikes. The future of SAM technology is moving toward greater autonomy and even artificial intelligence. SAMs are becoming smarter, faster, and more adaptable to new types of threats. And in the future, we may see systems that can independently assess threats, deploy countermeasures, and coordinate with other defense systems without human input. It's fascinating evolution, one that will no doubt continue to shape the landscape of modern warfare, but also with some thinking involved. So next time you think about air defense, remember that SAMs are doing more than just firing missiles. They're using radar, advanced targeting, and coordination to protect vital assets from above. And they are a critical line of defense in a world where control of the skies can determine the outcome of a conflict. So thanks for tuning into Outside Views Military, where we break down the systems that can keep us safe. And remember, while SAMs are great for air defense, I'm glad we don't need them to protect us at the moment, at least for the time being. Until next time, and the next video is right here in the end screen.